Hi, so I'm going to go through the speed, distance, time MathWatch questions that you will have done, hopefully yesterday. I'm going to do it in order, so 1, 2, 3, 4, 5, 6, 7, 8. Skip to wherever part in the video you need to be. So I know some of us just got the last two wrong, so you might just want to skip to the last however many minutes and just watch them. But let's make a start right from the beginning. So this is probably as basic as it gets. We like to talk about GCSE. When you come to do a question, you probably won't get a question like this explicitly on the higher paper. You'll get questions more like the middle of this task, and some stuff we'll look at in other lessons. But you need to know this knowledge to be able to answer everything else, so this is why it's on here, so it's not a complete waste of your time to master this basic skill. One thing we need to know and remember, that speed equals to distance over time, and some people find it useful to draw it as a triangle, so speed equals distance over time. So see how I kind of fit that in my triangle, because you've got to get the triangle right, and some people like to split it into there. And what the idea of this is you cover up what you want to find, and it tells you what sum to do. So if I cover up D with my cursor here, I want to do speed times by time. So this triangle down here, this line means times. And if I'm wanting to find the time, I've got distance over time. So this line here, that means divide. So if I'm wanting to find the speed, I'm going to do distance divided by time, and etc. I'll copy and paste that little triangle over actually to each question with my little snipping tool, because I think it'll be useful to us each question. I know I don't have to draw it out every time. So we're walking a distance of 15 miles in a time of 6 hours. Always take care of what units they're using. They try and trick you out by giving you stuff in minutes or minutes, and you've got to convert that to hours before you do miles, before you can do your calculation. So work out the average speed. So we want to find speed, so let's cover that up. Speed equals to distance divided by time. So speed equals to the distance. Oh, why have I done that? Wrong way around. Speed equals to the distance divided by the time. So that will get me 2.5, and we've done miles divided by hour, and that is going to be miles per hour. There's a few ways we write this. That means the same. These two means the same. People generally write this slash, but what it does mean a division. They just don't format it properly. Or people put miles per hour. That is just the worded way of saying what I've done there. Okay, so 2.5 miles per hour. Always check your answer makes sense as well. 2.5 miles per hour is a sensible walking speed. If you get the answer as like 80, you've definitely got it wrong, because you can't walk at 80 miles an hour. Okay. Let me get my ginormous triangle. Let's get him there. I'll copy that one. So, Tim drives at an average speed of 80 kilometers for a time of 3 hours and 45 minutes. We need this as an actual 3 point something hours. We don't know how to calculate with hours and minutes as both units. So 45 minutes, if you do the amount of minutes divided by 60, because that's how many is in an hour, that is going to tell you the decimal amount. So this is going to be 3.75 hours. So that's what we need to do our calculation with. Again, like I say, always check your Units, this is how they try and trick us out a little bit. So, work out how many kilometres Tim drives. So we want to find the distance. So cover up distance. So we want to do speed times time. So distance equals to speed multiplied by time. So 80 times by 3.75. See how we couldn't have done 80 times by 3 hours 45 minutes? That doesn't make sense. And when we do that, we get 300. Think about your units. How many kilometres does he go? So he goes 300 kilometres. Okay, next question. Let me get this here. Work out the average speed. So we've got a distance of 200 meters. We've got a time of 25 seconds. Here we've got different units, but we don't need to convert them. A very common thing you'll have heard is meters per second. It's very much a thing they use in science, because they consider such small things that they're going fast, but because they're so small, they're not going to be traveling over huge distances. Meters per second is a really good. Miles per hour, kilometers per hour, meters per second are generally your three you're going to hear. So if you get units that match up like that, you don't need to do any conversions. Like, you don't need to change this to hours or anything. Work out the speed. So cover up speed. Speed equals to distance divided by time. So 200 divided by 25. That is just going to give me 8 meters per second. You could also write it as meters per second. I generally prefer the little slash line. Okay, question 4. This one wasn't too much more difficult. You just had to kind of pull something from the diagram. So we want to find what the speed is. We know speed equals to distance over time. We've just done that for 2 of the questions. And time is 0.5 seconds. Because it says that here they were taken 0.5 seconds apart. Distance we're going to have to take from the diagram. Each little jump is 0.8 meters. So let's see how far we've got to jump to get from front of the car to the front of the car. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I need to do 9 lots of 0.8 meters or 80 centimeters. 9 times 0.8. And that is going to get me 7.2 meters. So going down here, distance 7.2 meters divided by 0.5. When we divide by 0.5, we're really timesing by 2, or you can get a calculator out and have a go at that. We will get 14.4. This is in meters. The time is in seconds, so it's meters per second. Not really the best indication of a car's speed. We like talking miles per hour, don't we? But there you go. So the driving distance between Manchester and London is 195 miles. Ferris intends to travel from Manchester to London by coach. The coach will leave at 3:30 p.m. He assumes that the coach will travel at an average speed of 50 miles per hour, so constantly going 50 miles per hour throughout the whole journey. Will he arrive in time? I mean, have I copied the full question? Do we even have a... Oh, not will he arrive in time. When will he arrive? That's a further question. I think that's the next question if we have to check if he arrives in time. Okay, so let's get our little triangle and let's write down some information we've got. So we know the distance is 195 miles. We know the speed is 50 miles per hour. So we actually want to find the time. So cover up time on our little triangle. We need to do, so time equals to distance divided by speed. So I need to do distance 195 divided by 50. That's going to get me 3.9. However, 3.9 isn't particularly a time. We need to have that as 3 hours and so many minutes. You can think, well, what is 0.9? What is 0.9 of an hour? So 0.9 of 60. 0.9 is the same as 9/10. So what is 9/10 of 60? That is 54, so 54 minutes. Also on your calculator, if you had 3.9 in your calculator display like you would after that calculation, there is a button that looks like this. And it's got fact above it, so we've used that for factorials before. If you press that button without shift or anything, that will convert it and it will say this. That's what your calculator was saying. That means 3 hours, 54 minutes, and no seconds. So, we know that this is going to be 3 hours and 54 minutes. So, when is his arrival time? Well, that's 3 hours and 54 minutes past 3:30 p.m. So, his arrival time would be 7:24 p.m. It actually turns out that the coach has a lower average speed. What will this happen to the time? Well, if we travel slower, it's going to take us longer to get there. So we'll arrive later. We don't know how much later because we don't know the drop of speed, but we just need to say that we're going to arrive later. Okay, Kim drives... Ooh, Rotherham. Never thought I'd see Rotherham in a question. Drives 156 miles from Rotherham to London. Drives at an average speed of 60 miles per hour. So see, as soon as I read the question, I'm just writing down everything I can see. She leaves Rotherham at 7:30 a.m. Does she arrive in London by 10 a.m? So I didn't write the distance down. So we want to find the time. So let's get my triangle. From this, we're going to cover up the time. So we know that time equals distance over speed. So I'm going to do 156 over 60. That gets me 2.75. I'm going to press that little button to convert it. Or you can use the other method. You might just be able to spot this one. That's 2 hours and 45 minutes. So arrival time is going to be 2 hours 45 minutes after 7:30. So we're going to arrive at 2 hours later would be 9:30, 45 minutes would be 10:15. So actually, no, she does not arrive in time. Oh, sorry, I think I've done the right working out, but I did 165 in my calculator, so for this, you should get 2.6, and when you convert that, you should get 2 hours, 36 minutes, so this should be 10:06 a.m, still the same answer. That she does not arrive in time. Okay, these final two questions are the ones that are a little bit trickier, where you've got two parts of a journey. And this method I'm going to use here is one that's quite new to me, but I think is amazing. I've never been able to answer these questions so easy since I've been doing this method. It just makes all the confusing bit of it seem super duper easy, and you're going to have practice with this when we do density questions and pressure questions, and then when we revisit this. So anything with compound measures, which is generally them 3 at GCSE, this method when you seem to have two different sections or two different objects or two different parts of a journey, this method is going to help you out loads, so I would definitely follow this technique all the time. and practice it. So we are going from Bristol to Cardiff, and we're also going from Cardiff to Swansea, and then we've got an overall speed, distance and time. So like before, when every time I got a piece of information I was writing it down, because I've got two parts of a journey here, I'm going to make a table to store my information. I might need this for in a bit, so I'm going to just pop that in the corner there. So anything I write in this column here, this is going to be the speed for the part from Bristol to Cardiff. This is going to be the distance of Bristol to Cardiff. This is the time of Bristol to Cardiff. This is the speed of Cardiff to Swansea, the distance of Cardiff to Swansea, and the time of Cardiff to Swansea. This is the overall, so the overall journey getting from Bristol to Cardiff, then to Swansea. What's the total distance? What's the total time? And what is the total average speed? So let's just go ahead and start filling this in, and I'll cross it off as I'm doing it. I'll do it in blue, and I'll do the new stuff in red. So Anil completes the 72-kilometre journey between Bristol and Cardiff. So Bristol and Cardiff, 72 kilometres. That's the distance. In 48 minutes. Remember, to get this as a decimal, we want to do 48 over 60. So 48 divided by 60. That is going to be 0.8 hours. So we've got that. Then drives 69 kilometres from Cardiff to Swansea. So 69 kilometres there. At an average speed, so his speed from Cardiff to Swansea is 60. Okay, so that's all the information I can get from the question. Can we see for this part of it, we can actually find the speed of Bristol to Cardiff because we've got the distance and the time. So, cover up our speed. Speed equals distance over time. So, hopefully I've left myself enough room in these boxes to do the working out. So speed equals distance over time. So that is going to be 72 divided by 0.8. That is going to be 90 kilometers per hour. The average speed for the total journey, actually, once we get this box, that will be our answer. Be careful, you can't just add these two together or add them together and divide by 2, because the journeys will be different lengths. So follow the method I'm doing and leave generally that one right till the end. To find this, you need these two boxes down here. So, unlike that one, we can find the total distance, because if he's travelled 72 kilometres and 69 kilometres, 72 plus 69, well, he's travelled a total of 141 kilometres. And we can find this through our triangle. We're trying to find time, cover that up. So we need to do distance divided by speed. So time equals distance divided by speed. So in this case, time equals to 69 divided by 60. That is going to be 1.15 hours. You probably just want to leave it like that because we're going to add these together. And it'll be a lot easier than converting it and then having to reconvert it back again. So, this box here, we can just do 0.8 plus 1.15. Because if it's taken him 0.8 hours or 48 minutes, and then it's taken him an hour and 15. And at 1.15, I'm not sure what that would be in minutes. But that would have taken him 1.95 hours. So now, using this column here, we can find our answer. So see how we've found the overall time and the overall distance from using this table. Now we can do this. Speed equals distance over time. So the distance is 141. The time is 1.95. So he has travelled an average speed of 72.3 kilometers per hour. So this is our final answer. So that table really just helps me set it out, and I even like to use two colours when I'm not working on a computer. I write in the information that I've got from the question in one colour, then I'll write the information I find in a different colour. Okay, this question, I'm going to set the table up. You might just want to pause it and see if you can finish it off. So we're going from York to Leeds, and then we're going from Leeds to Blackpool. Then we've got an overall. We've got speed, distance, time. Okay, my table is there. I'm just going to get my triangle back. Okay, so maybe you just want to pause it and see if you can have a go at this one now, judging from what I've spoke about in the last one. But if not, I'm just going to go through it now. So in blue, I'm going to fill in what's in the question. 45 kilometres from York to Leeds. So the distance is 45. 42 kilometres from Leeds to Blackpool. So straight away, actually, let's start filling this in. I can say, well, this is going to be 87 kilometres. You don't need to fill in your units, but I like to. That's just me. So the average speed between York and Leeds, so speed, York, Leeds, is 54 kilometres per hour. It also took him 35 minutes to get from Leeds to Blackpool. So the time here is 35 minutes. We need to do 35 over 60. And that is going to be, I'm going to leave it as a fraction because the decimal is actually not nice. It's a recurring decimal. And I think leaving it as that would be nicer. If you want to get some perspective on it, it's about 0.58 hours. So it's roughly equal to 0.58 hours. Let's double check I've got that right. So that is from Leeds to Blackpool. Okay, bro. So we can see from this that looking down our columns, we can figure this out, and we can figure this out, can't we? And then from the bottom line, we can figure out the total time, and then we can figure out what's in the top right. So, time, cover that up. Time equals to distance over speed. So this is going to be equal to distance, which is 45, over the speed, which is 54. That is going to be, again, I'm going to leave it as a fraction because it's a recurring decimal, 5 over 6 hours. We can add fractions. You could probably do this in your head. If we make that, that'll be 10 over 12. So it'll be 17 over 12 hours. Or you can just do it on your calculator to double check you are right. 5 over 6 plus 7 over 12. I am correct. And I'm going to leave it as that again, just because it's another recurring decimal. I want to get this perfect as possible, so working with fractions is always more accurate. And then figuring out this, well, the easiest one, speed equals distance over time. Distance is 42, and over, well, that's over 7 over 12. That basically means 42 divided by 7 over 12. You've got a calculator, so dividing by a fraction shouldn't scare you. You can even just type it in with a fraction on the bottom of so like a double fraction. And that gets me a nice number of 72 kilometers per hour. Again, you can't just add these together or add and divide by 2 because these aren't an equal amount of time spent on them. You've got to work from this final column to find the top right. So, what's colour I haven't used? Well, I haven't used black. So, let's go here. Speed equals distance over time. So, distance is 87. The time is 17 over 12. So, that's 87 divided by 17 over 12. Let's have a go at that. And that gets me a speed of 61.41 0.1176. I'm going to leave it as just 0.4 kilometers per hour. And that is my final answer. So well done if you paused it and had a go. We'll see some more questions like this with speed and with density. Density is a really popular one in exams, so we'll focus on that a lot. Okay, that's it from me. Thank you.